So with this question, the first thing to notice is that yes, we have a natural log, but more importantly, we have a variable in the numerator divided by a variable in the denominator, and that means that we need to use our quotient rule. So I've set that up. I have my natural log of x as the top function, bottom function is x to the 7th, took the derivative of the bottom function. And then for this natural log, that is going to be our argument's derivative over a. So we first have to decide what our argument is, and that again is the first thing that is right after the first term, right after the ln notation. So my argument will be equal to x, and then the derivative of the argument is just 1. And again, you can just memorize natural log of x is going to be equal to 1 over x when you take the derivative. All right, so now we plug this into the quotient rule. So we will have our bottom function, which is x to the 7th, times the derivative of the top, 1 over x, minus, and then we have our top function, natural log of x, times the derivative of the bottom, x times, or 7 times x to the 6th. Now, be super duper careful here. You are not saying that 7x to the 6th is part of the natural log's argument. So I would put little parentheses here just to emphasize that that is a separate term, separate factor, and it has nothing to do with the argument of our natural log. That is then over the bottom squared. So we have x to the 7th, and then we square that. Now, you cannot leave that as a respectable final answer. We have to simplify. Now, there's a very obvious simplification that can happen here, because if you look at this first term, you have x to the 7th and then x to the 1st in the denominator. So if I simplify that to begin, I will have x to the 6th, subtracting their exponents, minus natural log of x times 7x to the 6th, all over my x to the 7th raised again to the 2nd power. I will multiply their exponents and get x to the 14th power. Now, remember that with the quotient rule and product rule, we either distribute or we factor out a GCF. And if you look at both terms, the term before the subtraction sign, the term after the subtraction sign, they have a common GCF here. They both have this x to the 6th, x to the 6th factor. So I will factor out my GCF of x to the 6th. So that will give us x to the 6th. Now be careful here, because when I factor out x to the 6th, dividing by x to the 6th, and I will have a 1 left over. So it's not going to just completely vanish to 0. It will still have a placeholder 1 there, because like 3 over 3 is 1, x to the 6th over x to the 6th is 1. Then we have minus. Now the x to the 6th, that is going to be again pulled out as part of our GCF, and then we'll have 7 times the natural log of x left over. And you'll notice I put the little 7 in front because that really is playing the role of a coefficient. All right, and then we divide that by x to the 14th. Now, we're not done yet, because if we look at this x to the 6th factor, this x to the 14th factor, we can simplify that further. So we subtract the exponents. The 6 minus the 14 is going to give us a negative 8, and we can then put that in the denominator as x to the 8th, and then 1 minus 7 natural log of x. And that is our final simplified answer.